Hey there, Vince here, and welcome to a fabulously floppy circuit rewind. So one thing I've covered on this channel before is archiving old CDs, putting them on the Internet Archive for other people to use, because the amount of times that I've personally had to go on the Internet Archive to download content and get an old system up and running, whether it's an old piece of software, an old driver, old operating system, whatever, you know. It's been a very valuable resource, and I figured I have a lot of discs that are not on there yet, so let's dump them, get them uploaded for the next nerd who wants to go and restore an old PC. Well, that was CDs. CDs, DVDs, that's fairly easy. There's good utilities for that out there. Floppies, it turns out there are some good utilities too, but I didn't want good, I wanted great. In a recent video that I published, I showcased the oscilloscope that I just got, showcasing that digital computers still live in an analog world. So what we think of as a 1 or 0, there's actually like a whole array of voltages in between, and depending on where that voltage sits, for instance, a 5-volt signal needs to be above 4 volts to register as a 1 or below 2 volts to register as a 0, just as an example, and anything in between is kind of floating. Well, what if we recorded each of those voltages at certain time intervals more frequently than the actual clock signal, and then we went back and reanalyzed that information to see what those floating values probably should have been based on whether they're trending upwards or trending downwards, things like that. We could do that with an oscilloscope. And there are some tools with an oscilloscope to record and analyze and then process that data. But what if we wanted to do that with magnetic information or magnetic flux transitions? I'm still new to this myself, but I'm familiar with what hardware I needed, and I'm somewhat familiar with the tooling to do this. I went ahead and got one of these. It's called a Greaseweazle. It's this little circuit board inside of here, and I've already 3D printed a case and mounted it inside of this case and added a power cable, because what this is for is a traditional floppy drive. The way this works is actually fairly straightforward. From the Greaseweazle, I'm just going to plug in the power to the floppy, and then I'm going to plug in, yeah, it's going to be a mess. I'm going to plug in my floppy cable here, which is super long, and then get this plugged into the drive. And then I'm just going to somehow close this case up. And there. Greaseweazle. So before I show this thing in action, one of the things I'm probably best at doing on this channel is making custom cables. So first off, the power cable that I'm using is actually one of the audio cables, a spare one, because I bought a whole kit of these. They're just 4-pin cables for the arcade cabinet when I was doing the audio on that, and it works perfectly for this. And now this floppy cable here, I'm going to do what I'm best at. And I've been using this, by the way, with this giant cable, and I wanted to actually do the cable mod on video. So that way I can finally button up this 3D enclosure that I have. So now you get to see me do it. First things first is the larger connector here for a 5 1/4 drive. I'm just going to say goodbye to. So I'm going to take some nice heavy duty scissors and just like that, it's gone. And then for the rest of this cable here, what I've decided to do is I'm going to cut that down too. But first, let's see, where is the pinout on this? This is where I was screwing myself up before. I want to make sure I don't mess this up. All right, so that faces that way, that faces that way. So what I'm going to do is I'm going to add an extra thing on this. And I'm just, mine is keyed, the original one was not, so I'm just making sure I don't get this backwards. And the differentiator between the A and B floppy drive is this little twist on the cable. So I need to retain that twist because I want this to be the A drive to make the commands easier. I'm just going to slide this new thing in here, this new end. And that should be exact. Of course, as soon as I do that, I realize I did it upside down. That's why you measure 5 times and cut once. So let's get this rotated, because it's going to sit like this inside of here. Yeah, I had that backwards. All right, so let's get this in here, slide that back in, validate exactly how this looks, because I'm looking at the board here to see where pin 1 is, which is this red stripe, matching to where the key is for this clip. So let's get this lined up. That's probably about a good amount of length, considering it's just going to loop really, really shortly there, and I just need to have that twist in there. So let's get this pushed up just a little more. I'm going to have it right about there. And then what I have is big chunky boy. The way this works is I just put the cable in, and I get the key. The crimp tool is actually keyed for the cable. So come on, get in there, key. Oh, that popped out. Of course, I'm being an idiot. Let's get that back in there slightly. Slide this back in, get it keyed. And then I have to try to get this lined up nice and straight. So I usually pull this down and try to get the two perfectly straight. And then just clunk, just like that. You can actually feel the pins getting pushed into the wires. But so far, that doesn't do us a whole hell of a lot. We just have an extra thing in this extra long cable. So, like we did before, just going to take the scissors here, cut that down, and we now have a right-size floppy cable that still has the twist in it that we need. So that new slot that we have, or the new keyed connector, goes into the bottom like so. And now we don't have all that slop everywhere. And then this is just going to slide back around, plug directly into the drive. And all of that excess cable, there's actually room underneath, or yeah, I believe underneath the drive, there should be enough room for that to sit. And this will just barely sit in here like so. And I don't have the screws over there, so I'm going to do that off camera. But at least for now, oh right, these are actually friction fit. That's right, I forgot about that. So other than the fact it's not screwed in, this gives us an idea of what this whole unit's going to look like. Nice and buttoned up, and also I have an LED in the mail to put in this. There's actually a header on the board to have a front LED for when you have enclosures like this, when you can't see the board. And what this gives us is just a USB-C interface. USB-C is off of a normal PC, just a normal USB port. It's actually powerful enough to power that board and the floppy drive. So this is all we need. And now I just plug it into the computer. All right, assuming all went well, I'm now going to go to the computer and type in a command. What I'm doing specifically is I'm doing a raw read, because I want to read, like I said, the flux transition information, not just the ones and zeros. So normally with a drive, if you just use a normal drive, between the drive and the controller, it will interpret the magnetic data coming off of the drive and convert that to ones and zeros for the operating system to read. And it'll be specific to the format of whatever operating system and hardware you're using. So for instance, IBM PCs, which these disks are formatted for, these are probably 1.44 meg disks or 720K disks. It will read that specific format that is the IBM standard going all the way back to the XT computers. But for instance, Apple or Amiga or other companies had different methods and different formats for their floppy disks. But using this specific method, the Greaseweazle controller can tell the floppy drive to read it at different track depths. So instead of saying, hey, be perfectly aligned to this track in IBM style, how about we go 10%, 20%, 30%, so on and so forth, and it can realign itself dynamically based on these different disk formats. And it can also read more data on a track. Like I said, rather than exactly where the one or the zero should be, it will continuously read the entire track to basically pull in more information from it. And I know I'm describing this terribly. There's better documentation on the website than what I'm saying right now. Instead of like a 1.44 meg disk being a 1.44 meg image file, this generates about 50 megs per image file because it's collecting a lot more information, and then use another tool later on to convert that back into a floppy image file. But by doing it this way, we can reanalyze these disks at a later date in case we find that maybe there's some copy protection, for instance, with games. Games would often actually put extra information in between tracks and had custom software to tell the drive, hey, instead of going from track 1 to track 2, go to track 1 to track 1.5, read this small little section to validate if it's actually a real disk or not. And so with a drive like this and with this configuration with the Greaseweazle, it's actually pulling in that information. So if we regenerate a new disk using the flux transitions instead, all the copy protection will remain in place, where normally that information would be lost. So anyway, I'm now going to get to it. Let's go here to the command, Shanghai 2, and it's disk 1. And also how I have format set to IBM.scan. What that means, if it's an IBM 720K or an IBM 1.44 meg disk, this program will figure it out automatically so you don't have to guess which disk it is, which is useful for me because I'm doing a lot of disks right now. So as you can see, it's now going through track by track, sector by sector, reading every little piece of information off of this disk that it can find. I do believe that it says it's 9 sectors, that means this is a 720K disk, but again, I don't care. This will do it, it'll do whatever it needs to do and spit out the file, and then I can work with that later. The reason I'm going through this though is I was interested in dumping my own floppy disks, and so I decided to get this set up, but while I was waiting for this to arrive in the mail, on eBay I saw this auction for about 150 disks. It did not say what was in the lot, it just showed the top of the box, so you can see like 5 or 6 disks and that's it. And I'm like, okay, there's some commercial disks, there's some homemade disks, whatever, let's buy the box and see what happens. It was about 75% commercial disks, 25%, business or homemade disks. And I'm just like, this is really cool, I want to dump a lot of this because it's, a lot of the disks were system utilities, not games, not normal programs, but system utilities, like specific hard drive utilities that I personally was already using on the 486 that I recently got. But it's different versions of it, so if I need to upgrade or downgrade for whatever reason, I have like several versions of those programs now. So after I got that, and I was still waiting for this to arrive, I looked back at that same seller and they had a second box of 150 disks, as well as Shanghai Dragon's Eye. A game that I always loved on the Super Nintendo. All right. Real quick, swapping discs. And so I decided to purchase the second box as well as these discs separately. So they shipped the second lot, these discs and the second box to me all as one giant box. So that meant I now had over 300 floppy disks to dump. On top of that, I already had at least 100 sitting around here because I have various copies of DOS, Windows, and other utilities. So now I have a way to do these really high quality dumps, and I'm going to have both the flux transition files and the converted FLP image files that you can immediately load up in a virtual machine or dump them back to a physical floppy drive or use like a floppy emulator. I'll have both versions of all of these files available on the Internet Archive. For these commercial disks, I'll just validate that they are what they are, that they're actually good, they weren't wiped or anything, and then upload them. For the business or homemade disks, I'm going to validate each disk, what's on them, before I make a decision if any of those are going to get updated or not, because I don't want to give out any private business information, private customer information, like private tax files or anything like that. So I'm going to do my due diligence and validate what each disk is before they go online. So those are going to take more time. Like these commercial disks should be fairly quick and easy because, for instance, a Norton Utilities disk, I check the floppy image, has like Norton.exe, and then I put it in the computer, I go run the exe, it runs what it says it's supposed to be. That's a fairly easy validation. But if I start seeing like a PDF or like a Word doc or something like that, that's going to take more time to go through each one individually to see what's on them. And some of these floppies may have 100 files on them. Anyway, in the time that I was ranting, that is both discs of Shanghai 2 Dragon's Eye on, let's see, this supports IBM PC, XT, AT, PS1, PS2, Tandy 1000 series, and 100% compatibles. So, desktop computers, basically. Anything IBM compatible, this game will run on. Feature bins here. So I got the Greaseweazle all nice and buttoned up inside of my case here, and it's looking fantastic. Also, if we go over here to the laptop, I forgot to show you how to convert a raw flux dump into an actual floppy image. So here I'm going to run the HxC command with an input from one of our SCP files, and then I'm going to do an output to just a normal image file. Now I hit enter. It takes a few seconds to run. And then if we check our dump folder here, you can see here that we now have an IMG file which can be loaded up into a virtual machine or written to an actual floppy disk. Anyway, I'll have links down below for the Greaseweazle, for the utilities for it, all the conversion tools that I'm doing, and then once I start getting things on the Internet Archive, I'll have that linked as well. Right now it's just CDs that I dumped a year ago, but I have a whole new stack of CDs I'm going to be dumping, as well as these floppies. They're all going to be up there. I'm going to do the thing with my flatbed scanner to actually scan each of the disk labels too, so that way they're all nice and clean. But otherwise, I just wanted to showcase this real quick, showcase making a custom cable in just a few seconds and getting this thing all buttoned up and looking clean. And now, after this, I'm going to go get the screws in and have this finalized. But other than that, until next time, later, y'all.